Okay, so now with this configuration, you're going to notice a slightly different situation. They're going to tell you eventually in the experiment to set it up this way where you have, let me get in a little closer. What you're going to notice here is that the fulcrum is not at the 50 centimeter mark now. It's actually at the 40 centimeter mark. You maybe can't see the 40, but you can see the 30 and the 50 on each side. The fulcrum is at the 40 centimeter mark. So when you do it this way, you have another torque involved that you didn't have before, and that would be the torque that's created by the weight of the stick itself. So here at the 50 centimeter mark, we could assume that, let's say, just to make it simple, let's say all the mass of the meter stick is concentrated at the 50 centimeter mark. It might not be exactly at 50, but close to 50. So basically you have another force acting that does create a torque. So you have to kind of pretend that, say if there was an invisible hanger with some mass on it here, hanging at the 50 centimeter mark, and that amount of mass is equal to the weight, or the mass of the meter stick itself. That's what you have. So you have to consider that weight or mass of the stick itself as being one of the torques. Okay, so if we were using the fulcrum as the moment arm again, so you'd be talking about from the 50 centimeter mark to the 40 centimeter mark. Okay, now that brings up another thing, and we want to make a distinction between the fulcrum and the axis of rotation. Okay, most of the experiment you're going to treat them as the same thing. The fulcrum is actually the physical location right there where the meter stick is resting. Okay, and for most of the things it has you do in the experiment, you're going to treat that as the point of rotation or the axis of rotation. But you could consider any point on the stick as being the axis of rotation. Okay, it could be the 30 centimeter mark or the 50 centimeter mark or the 60 centimeter mark or any place on the stick. You could say that's the axis of rotation, and that might not be the same as the fulcrum, and you could figure out torques considering that other point as the axis of rotation. Your moment arms would be different. You're going to find out when you do this that you can make choices that eliminate some things and make some things simpler, and so that's why they're often chosen. But the axis of rotation and the fulcrum are not always the same thing. They are in the first part of the experiment, but then it's going to get you into some situations where they're not the same thing. Okay, so just to make that clear. In other words, the axis of rotation is not necessarily at the same place as the fulcrum. The fulcrum is pretty well fixed. It's physical, but the axis of rotation is theoretical and it's arbitrary. Okay, you might notice this doesn't look exactly horizontal, but you know, I could fiddle around with it all day and it would take a long time to get it really perfect. But sometimes you just have to call it good enough, and I'm going to call that good enough. Okay.